Good morning, students. This is Maithili, Assistant Professor, Department of Mathematics, St. Anne's Arts and Science College. Dear students, today we are going to see the next unit, that is a unit 2, differential equation. First, let us see the definitions of the differential equation. So, define differential equation. The differential equation is one which contains the variable and the derivative of the dependent variable. So, differential equation is one which contains the variable and the derivative of the dependent variable. The differential equation having a single independent variable is called ordinary differential equation. Suppose if the differential equation, there is a differential equation which having the single independent variable, that is called the ordinary differential equation. And same, the differential equation having two or more independent variables are called the partial differential equation. So, ordinary differential equation is nothing but the differential equation having a single independent variable. If the differential equation having two or more independent variable means is called the partial differential equation. Okay, therefore these are the definition of the differential equations. The next definition, linear differential equation of second order with constant coefficient. First of all, the general form of the linear differential equation of the second order with constant coefficient is a into d square y by dx square plus b into dy by dx plus cy is equal to f. For this is a general form of the linear differential equation of second order. For second order is a second order derivative with constant coefficient. A d square y by dx square plus b dy by dx plus cy is equal to f. Where this A, B, C are constant. A, B, C are constant. And capital F, the right hand side F is nothing but the function of x. The solution to this equation consists of two parts. The solution of this differential equation consists of two parts. First, number one is a complementary function with arbitrary equation. First solution is a complementary function, and second one is a particular integral without any arbitrary function. For these two parts are the solution of the second order differential equation. Therefore, the general solution can be written as, this is a complete solution form, y is equal to complementary function plus particular integral. Okay. Next, how can we find the complementary function? This is second next topic is how can we find the complementary function. Suppose let us a given equation is of the form am square plus bm plus c is equal to 0 be the auxiliary equation. Since it is a quadratic equation, so quadratic equation means it has two roots, right? Quadratic equation means it has two roots. Case 1, suppose if the roots are real and distinct. Suppose if we find the two roots are real and distinct, that is, means real and distinct is nothing but called two roots are not equal. That is, m1 is not equal to m2 means the complementary function can be written as c1 e power m1x plus c2 e power m2x. This is the first case when the roots are real and distinct. Case 2, if the roots are real and equal means, that is m1 is equal to m2. Both the roots are equal means we have to take it as m. So in this case, the complementary function is c1x plus c2 into e power mx or c1 plus c2x into e power mx. For in this case, the complementary functions can be written in two ways. c1x plus c2 into e power mx, this is also right, or c1 plus c2x into e power mx. Case 3. Suppose if the roots are in imaginary, that is alpha plus I beta means complementary function is e power alpha x c1 cos beta x plus c2 sin beta x. For this is the complementary function for the case 3 if the roots are imaginary. Okay, let us see some problems. See the first one. Solve y2 dash plus y dash minus 6y is equal to 0. For this is second order equation, y2 dash plus y dash minus 6y is equal to 0. First, see the solution. First, write the given equation can be written as, so y2 dash means we have to write d square, y dash is nothing but d minus 6 of y. That is d square of y is nothing but y2 dash. d of y is equal to y dash minus 6. So the given equation can be written like this: d square plus d minus 6 of y is equal to 0. Next, we have to write the auxiliary equation. So auxiliary equation is nothing but we have to write the equation as m. That is m square plus m minus 6 is equal to 0. Now we have to solve the equation. So after solving the equation, we get two roots. That is m minus 2 is m plus 3 is equal to 0. That is m minus 2 is equal to 0 means m is equal to 2. M plus 3 is equal to 0 means m is equal to minus 3. So we get one root m1 is equal to 2 and another root m2 is equal to minus 3. See, both the roots are not equal. That is, the two roots are not equal. That is, the roots are real and distinct. Distinct is nothing but not equal. So in this case, what is the complementary function? C1 e power m1x plus C2 e power m2x. Therefore, C1 e power 2x plus C2 e power minus 3x. Therefore, the solution is y is equal to C1 e power 2x plus C2 e power minus 3x. Right. See the next sum. Solve d square plus 2d plus 1 of y is equal to 0. First write the given equation. So the equation can be directly in the form of d square plus 2d plus 1 of y is equal to 0. Write the auxiliary equation is m square plus 2m plus 1 is equal to 0. After solving the equation, we get the two roots. That is m plus 1 into m plus 1 is equal to 0. That is m is equal to minus 1, m is equal to minus 1. What is this? In this case, both the roots m1 is equal to m2 is equal to minus 1. Both are equal. So you have to take it m1 and m2 is equal to m. So what this is a case 2, that is the roots are real and equal. So the complementary function is c1 plus c2x into e power mx. That is nothing but c1 plus c2x into e power minus x. Therefore the solution y is equal to c1 plus c2x into e power minus x. Right. See the next sum. Solve d square plus 2d plus 5 of y is equal to 0. So write the auxiliary equation as m square plus 2m plus 5 is equal to 0. So in this case, we cannot able to solve this equation directly. So you have to use the formula method, the quadratic formula method. That is, what's the formula? Minus b plus or minus root of b square minus 4ac by 2e. So you have to use this method. So what is a? A is equal to m and b is equal to 2 and c is equal to 5. Therefore, m is equal to minus b plus or minus root of b square minus 4ac by 2a. So substituting all the values, we get the roots are minus 1 plus or minus 2y. Okay. So this is in the form of alpha plus or minus beta I. So that is nothing but alpha is equal to minus 1 and beta is equal to 2. So what is this case? The roots are imaginary. So the roots are imaginary means what is the complementary function, girls? E power alpha x c1 cos beta x plus c2 sin beta x. Therefore the complementary function is equal to e power minus x c1 cos 2x plus c2 sin 2x. Therefore, the solution is y is equal to e power minus x c1 cos 2x plus c2 sin 2x. Okay. For these are the problems of finding only complementary function. So next, how can we find the particular integral? So listen. So step 1, first write the particular integral as 1 by the given equation, that is given the differential equation, into what is given in the right hand side, that is nothing but e power alpha x. So 1 by the given equation into e power alpha x. Next step 2, we have to replace the d by alpha, that is you have to replace d by e power alpha x. No, so you have to replace d by alpha. Suppose for the failure case means that is in the form of 1 by 0 means we have to find the particular integral by using multiply the numerator by x and differentiate the denominator. This is the procedure. Multiply the numerator with x and differentiate the denominator into e power alpha x. So this is in the form of to find particular integral. See the problem, girls. Solve d square minus 3d plus 2 of y is equal to e power 4x. Therefore, the right hand side particular integral is we have to find. Right hand side is given.
First, we have to find the complementary function. Up to complementary is the same procedure. Okay, what is, write the given equation and write the auxiliary equation, find the roots and check whether the roots are real and equal, and then real and not equal, and then imaginary. See the condition. So in this problem, see the roots are m1 is not equal to m2, therefore the roots are real and distinct. So what is a complementary function? C1 e power x plus C2 e power 2x. So now complementary function is over. Next we have to find the particular integral. So how can we find the particular integral? First, particular integral is equal to 1 by, write the given differential equation. What is given in the problem? D square minus 3d plus 2 into, what is the right hand side is given? E power 4x. So what is alpha here? Alpha is equal to 4? No. So you have to substitute d is equal to 4. So we get 1 by 4 square minus 3 into 4 plus 2 into e power 4x. So we get 1 by 6 into e power 4x. Therefore, this is a particular integral. Now write the general solution. What is the general solution formula? Y is equal to particular integral plus complementary function. That is complementary function plus particular integral. So y is equal to, what is the complementary function we found, girls? C1 e power x plus C2 e power 2x. Plus what is the particular integral we find? 1 by 6 into e power 4x. Okay, this is a solution. See the next sum, the same procedure, but the problem given in the different way. See the equation 2 into d square y by dx square. This is nothing but y2 dash, right? Minus dy by dx minus y is equal to 4 into e power x. First write the given equation as in the d form, that is 2d square minus d minus 1 of y is equal to 4 e power x. First write the auxiliary equation in terms of m, that is 2m square minus m minus 1 is equal to 0. Find the roots. Here the roots are m1 is equal to 1 and m2 is equal to minus 1 by 2. That is the roots are real and distinct. So write the complementary function is c1 e power x plus c2 e power minus x by 2. Next we have to find the particular integral. Particular integral is nothing but 1 by, what is the given equation? 2d square minus d minus 1 into 4 e power x. What is the alpha value is nothing but 1. So put d is equal to 1 in the equation. So 1 by 2 into 1 minus 1 into 4 e power x. So we get 1 by 0 into 4 e power x. So 1 by 0 means it is in the failure case. Okay, failure case means next we have to find the particular integral by, see what? We have to multiply the numerator by x. So put x in the numerator divided by and differentiate the denominator. What is the denominator? Denominator is 2d square minus d minus 1. So differentiate the denominator, we get 4d minus 1. Okay, when we get the failure case, multiply the numerator with x. So put x in the numerator divided by and differentiate the denominator. What is denominator? 2d square minus d minus 1. Now differentiate this case 4d minus 1 into, write the term, right hand side 4 e power x. That is, again put d is equal to 1. So we get x by 3 into 4 e power x. So this is the particular. Suppose after again we get the failure case means, what is the same procedure? Multiply the numerator with x. What we get? X into x, it become x square. And again differentiate the denominator. What is the denominator is 4d minus 1. So after we differentiate, what we get? Simply 4. For the particular integral becomes x squared by 4. This is the procedure for finding the failure case. So we get in this problem, we get x by 3, 4 e power x, that is 4 by 3 x into e power x. Now write the solution. What is the solution? Complementary function plus particular integral. So we get y is equal to c1 e power x plus c2 e power minus x by 2 plus 4 by 3 x e power x. Okay. See the girls. Some problems are given. I gave 6 problems. Just do all the problem. First 2 problems are in the particular integral type and remaining 4 problems are only find complementary function. And see the fifth sum. Fifth sum is the third order. So we get d cube plus d square minus d minus 1 of y is equal to 0. So we get the third order degree equation. So we get 3 roots. Okay. So we get 3 roots means check 3 roots are real and distinct. But suppose when the 3 roots are not roots are real and distinct means what is the complementary function? Simply is nothing but c1 e power m1x plus c2 e power m2x plus c3 e power m1x. That's all. For the if the suppose if the roots are real and equal, means what is a complementary function? c1 c1 plus c2x plus c3x square into e power mx. That's all. Okay, girls. So just do try all the homework sums. If you have any doubt, means you can call me. I will clear your doubts. Right. Thank you.